Good morning to everyone. So this is Dr. Maheswara Rao, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering, Dundigal. So our course name is Fluid Mechanics. So today we are going to deal the topic boiling point and capillarity. So here boiling point means any liquid which will be converted into gas. So that is called a boiling point. And capillarity means nothing but a rise or fall of a liquid whenever you keep the small diameter tube in it. That is called capillarity. Here, boiling point means you can get the boiling, that means you can convert the liquid into gas by increasing the temperature, or without increasing temperature also you can boil the liquids by increasing the pressure. Here, capillarity is nothing but the rise or fall of a liquid in a small tube. So before going to that, we will learn that course outcomes. So at the end of the course, the student can be able to define what is fluid and its properties, and what is surface tension, and the relations in different conditions. So that is course outcome 1, that is CO1. So CO2, that means course outcome 2 is that student will be able to explain the Newton's law of viscosity. What is the Newton's law of viscosity, and what are the different types of fluids, what is the classification of fluids, and they can solve the problems also on the viscosity. That is course outcome 2. Then course outcome 3. So here the course outcome 3 is the capillary rise or fall in a given tube. Why this rise will occur? Why the fall will occur for a liquid whenever you keep a small tube? So that will be known at the end of this course, which is here course outcome 3. So if you go to the course outcome 4, CO4 is surface tension. So what is the surface tension, and where the applications are there? So in real life conditions, where the surface tension will applicable. And see the course outcome 5, CO5. So here, concept of capillarity and compressibility. So what is the capillarity? What is the compressibility? What is the concept of these capillarity and compressibility? It will be known by a student after completion of this course. That is a course outcome 5. If you see the last one, course outcome 6, it is a pipe flow. That means a fluid flowing in a pipe. So it will exert a friction. So if any two materials are flowing, that means relative to other material. So here pipe is not flowing, pipe will be there. So but liquid is flowing by touching the pipe surface. So that's why there will be a friction in the fluid. Okay. So by using that friction, it will lose the energy or pressure. So at different nodes, as you length of travel is increases. That is CO6. So today our topic is boiling point. The definition. What is the definition of boiling point here? Is the temperature at which liquid's vapor pressure equals the external pressure. So here, temperature at which liquid's vapor pressure equals to the external pressure, causing the liquid into a vapor. That means if a liquid is there, so it will have some internal energy. So it will also have some external force. So normally it is a atmospheric pressure. So what is the definition telling that? So if it is equal, so if the external pressure or internal pressure, if it is equals, then boiling will start. That means this liquid will be converted into gaseous form. That point is called boiling point. The key concepts of these boiling points. So there are two things here. One is effect of pressure. Another one is latent heat of vaporization. So what is this effect of pressure? Boiling point increases with increase in pressure and decreases with decrease in pressure. Here, the thing is that temperature and pressure. So if pressure is increasing at the constant pressure, constant temperature also, boiling will take place. Not only by increasing the temperature, even though the temperature is constant, the boiling can take place by increasing the pressure. So that is the key concept here, effect of pressure. So if pressure is increasing, okay, increasing the pressure, okay, the boiling point also increases. And the reverse also, if you decreasing the pressure and this boiling point also decreases. So that is the key concept here. That means it is takes the two things here. One is temperature and the pressure. So if temperature rises at the same pressure, evaporation will take place. That means boiling will take place. And temperature is constant, pressure is increases. Then also boiling point will start. Another one is here, latent heat of vaporization. So what is this latent heat of vaporization? The energy required to convert a unit mass of liquid into vapor. So here, unit mass of liquid. So if you take 1 gram or 1 kg, like that. So unit mass of liquid, if you make into, if you can convert, okay, how much energy is required? That energy is called latent heat of vaporization. That means if you want to convert a unit mass of liquid into vapor, then have to gas, okay, then the energy required is called the latent heat of vaporization. That means here the energy required to convert a unit mass of liquid into vapor without temperature change. Here, without temperature change, that means constant temperature. Okay. So temperature is constant. It is not increasing. We are not changing the temperature. It is not increasing. It is not decreasing. So we are maintaining the same temperature. Then the energy required to make or to convert that unit mass of liquid into a vapor, that energy is called the latent heat of vaporization here. Then capillarity. Okay. Capillarity, you can see this is a small tube. Okay. This is also a small tube. So here you can see the liquid is having U shape here, but here it is a inverted U shape. And the actual surface of the liquid is here, and the liquid is rising here. So which is called a capillarity rise here, which is HA. And here it is lowering than the actual surface of the liquid. Here it is lowering, that is, it is falling. That's why it is called capillary fall. It is a capillary rise, this is a capillary rise, and this is a capillary fall. So that means some liquids will rise. If you keep a small tube, in a liquid, okay, so some liquids will rise beyond the surface of this till here, okay, and some liquids will fall. So those will not rise, the opposite. So this is actual surface and this is here. So it is falling. So it is actual surface, but the surface is different. Okay. So these are two called capillary rise and capillary fall. Why it is happening? Here is nothing but the two words are there: adhesion, cohesion. What is the meaning of adhesion? And what is the cohesion here? Okay. So adhesion means it is nothing but the attraction between different materials of molecules. Different. Here, what is the different? The pipe material is different. Liquid material is different. If adhesion is more than the cohesion. Cohesion means what? The attraction between the same molecules. That is called cohesion. Attraction between the different materials are called adhesion. So same molecules, different molecules. So if adhesion is more, that means if it attracts other materials more than themselves, that means if X molecule and X molecule is here, there will be attraction, but here Y molecule is there, then if it is more, then it is adhesion. So X is attracting Y, not X. So these are the same molecules, which is called cohesion. Okay, and this is a different molecule. This is called adhesion. Okay, if adhesion is more, then the liquid will rise in a small tube because it attracts, the pipe material attracts the liquid. That's why it is rising. You can also see here U shape here. Okay, this is rising. This is rising because of adhesion. Here also rising. But whereas here another material, the example for this is water, and opposite one is the mercury. So here cohesion is more. Cohesion means what here? Attraction between the same particles. So same molecules. So here mercury means mercury molecules will have attraction, more attraction compared to the molecules of this pipe material. So here cohesion is more. That's why it is lowering the level. So here you can see here also inverted U shape here at the surface, and also here is the inverted U shape because cohesion is more than the adhesion. So then what will happen? There will be a fall in the surface level of the liquid inside the small tube, outside the small tube. So which is called a capillary fall. So this height is called capillary fall. This one is called rise, capillary rise. So water is having capillary rise, whereas mercury can show the capillary fall here. Okay. So you can also see this is a wetted, non-wetted. So that means because of adhesion is more, the particles will attract pipe material, but here non-wetted, this is particles will be repelled by the pipe material. So before going to this small formula, capillarity, how much height the liquid will rise in a small tube. H, this is the formula. Before going to that, we can know the practical application where this capillarity will be useful. So if the property is not there, there will not be any living matter. So what is the link with the living matter with the capillarity? So the practical applications are here. Earth will have water here somewhere. So here tree will be there. So the roots will take the water. There is no pumping the water from the underground water to here. It is not an overhead tank. But the water will travels, even though water table is this. Okay, below the ground, if there is gap also without water, this water will travel upwards due to the property of capillary rise. So that the tree will take that water and they will grow. So if the capillarity is not there, whenever water table is below than that roots, then water will never travel upwards because capillarity property is not there. Then all the trees, plants cannot grow. So if the trees, plants are not growing, then automatically all the living matter will die. So that's why this capillarity, very best application is that watering this tree or plant. So in the soil, the water travels upwards because the gap in the soil particles will act as a capillary tube, small tube. That's why water will go up so that it reaches the roots of the tree so that the plant will take the water. Another example is that stove. Okay, gas stove, kerosene stove like that. So if you know the stove here, okay. So some small cotton is there. Okay, the cotton will be inserted. So here is the kerosene. Okay. So then here you will make a fire. So this is a stove, kerosene stove. So due to property of kerosene, this capillarity, the kerosene is traveling upwards, so that it gives this. So lighting a lamp, okay, anyway, wax lamp also, wax lamp or kerosene lamp or ghee lamp, whatever it may be. Because of the capillarity rise only, the liquid is traveling upwards, we are getting the flame. So for cooking purpose, for lighting purpose, what else may be. This is another example for the capillarity. So if you see the formula, how much rise? H. This is the capital H. That is nothing but the rise of water level. How much is rise? Okay. You can see the formula here. 4 sigma cos theta by rho GD is the formula. Actually, how much you can know here. So first you will see this. H. H is the height of this rise of water. R is the radius of the tube. This small tube radius is R. Okay. Theta is the angle of contact between the liquid and solid. So this is the theta. This is the theta. So this is the surface of the tube and this is the slope of the liquid. So that is the theta by the sigma. Here, how much is the rise in the liquid? How will you know this? It is nothing but the weight. We can see here weight. So weight of water. Okay. Weight of water equals this upward pressure. So this is a force. You can see here a arrow mark. This is the upward pressure. So if you resolve that vertically, so it will become upward pressure. This is inclined pressure. It will become upward pressure. So the water will rise in a tube depending upon the weight of the fluid. So it equals, if weight is more, then what will happen? Whatever the liquid here rise, okay, that will be the same weight of water here. So whatever the liquid rises here, that will be due to the force applied by this capillarity here. The weight of the fluid is balanced with the vertical force. So whatever may be the force applied, vertical force by this capillarity, okay. So how much water is raised or that can take. So that is the is depending upon the weight of the fluid. Okay, it equal balances. Okay, the weight of the fluid is balanced with the vertical force caused by the surface tension. Here, surface tension is the what here? Surface tension. This is nothing but a surface tension. A force is called a surface tension. This force vertically resolve. So whatever the force upwards, that much water will be raised. If it is a smaller tube, very, very smaller tube, this force is same, then more water can be raised here. Here you can see diameter is the 2R, pipe diameter, it is the weight of water. Okay, H is the height of rise. The formula is 4 times sigma cos theta rho GD. Okay, so capillarity. See, for a clean glass in contact with water, so if it is a clean glass, it is having contact with water, it will have theta is the 0 degrees. Theta means here you can see here, this is the theta, 0 degrees. As the R decreases, H increases. You can see this. R and H are inversely proportional. Okay. If R decreases, H increases. If H decreases, R increases. Okay. So what is the R? What is the H here? H is the height of rise of fluid, water or liquid inside the small tube. Okay. And R is the radius of the small tube. So these R and H are the inversely proportional. Okay. So if one is rising, another is decreasing here. So but that means if you want more height, so if more height, you have to put the lesser diameter. So for a lesser diameter tube, so rise of liquid will be more based upon this statement. So here H is equal to 5 mm in tube of 5 mm diameter in 5. So if you summary this, so we have discussed the fluid mechanics course. The topic is boiling point and capillarity. Here outcomes are properties, definitions of fluids, surface tension, they will know. And Newton's law of viscosity also they can know. They can solve the problems on the viscosity. And what is the capillarity rise or capillarity fall, and surface tension concepts, and capillarity and compressibility concepts also they can know, and pipe friction, fluid friction, and pressure differences. What is the fall in pressure after traveling a certain distance? That is course outcomes. And boiling point definition, it is nothing but the external pressure equals to the internal pressure, then boiling point will start. The key points are effect of pressure. That means if pressure is increasing, boiling point is also increase, and pressure decreasing, boiling point also decrease. Latent of heat of vaporization means it is nothing but the energy required to convert it into a vapor of a certain mass of liquid. So that is the latent heat of vaporization. And if you see this, okay, so this is a capillarity rise and capillarity fall. So adhesion is more than the cohesion. Then it is a rise. Example is water. And cohesion is more than adhesion. That means the same particles will attract more than the attraction between the different particles. That is a cohesion is more. That is then there will be a fall. Fall, that means a capillary fall will be there. That is example is the mercury. And here is one formula there. Okay. See here how much water is lifted means depending upon the surface tension. So the surface tension, whatever the force that can be pulled, the weight of liquid. So that much rise will be there. The formula is here, H is equal to 4 sigma cos theta by rho GD. So where H is the height of the rise of the fluid in the small tube, and R is the radius of the tube. Okay. Theta is the angle of contact between the liquid and solid. And capillarity, here it is how much water is balanced. So that means there will be balance. So the capillarity, that means surface tension will not take all the water. So certain quantity of water will be taken by the force of the surface tension. So how much it will take, it depends upon the balancing the weight of fluid that is lifted. So whatever the force of surface tension, that much water will be lifted. So that will be a balance. So it is R and H. So R means here diameter of the small tube. H means the capillary rise or capillary fall. Okay. If R decreases, H increases. If R increases, H decreases. So the inversely proportional. So R and H are inversely proportional. That means small radius will have more rise, or bigger radius will have smaller rise of the liquid in the small tube. So references are K. Subramanya, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill, 2012. Another book is Modi PN and SM Seth Hydraulics and Fluid Mechanics, Standard Book House, 1980. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.